let's go ahead and talk about this plane question. So it says a jet travels 3,950 miles from Chicago to London, and that takes the same distance on the return trip. Total flying time is 16.5 hours. The return trip takes longer due to winds that are blowing from west to east. If the jet's average speed with no wind is 485 miles an hour, how much faster is the plane going on the trip there as opposed to coming home? Okay, lots of stuff to unpack here. So first, let's talk about this distance. So it says the jet travels 3,950 miles. I'm going to go ahead and label that right away as my distance. And it says it's the same distance on the return trip, so we're going to use that for both scenarios. Then it tells us the total flying time is 16.5 hours. So let's think about what's happening here. So we have our little airplane. Boop, boop. We're going to pretend that looks like an airplane. He's flying there, and then he's flying the same distance back. So if I want to write an equation and it told me the flying time, I'm going to say that the time it takes to go there, it plus the time it takes to go back is equal to the total time, and I'm going to input that 16.5. So it doesn't say that they're going the same speed, so I can't set them equal. I'm going to add both of their times, however long that is, and they equal 16.5. And so now it's telling me about some type of wind speed. So it says on the return trip, it takes longer due to winds that are blowing from west to east. So it tells us how fast the plane is going if there was no wind. So I'm going to start with that, 485 miles an hour. So here's on the way back. And it said it's going slower. It's because it's going into the wind. So imagine when you're running and you're running into the wind, it's really hard because it's like pushing against you. So you're going to go at a slower rate. So I'm going to take this 485 and I'm going to subtract whatever that wind is. So let's let x equal whatever the wind speed is. I'm not sure what that is, but I'm going to label it as x. And then on the way there, if the wind is blowing this way, then on the way there, I'm going to be going with the wind. So I'm going to be having a faster rate. So on the way there, I'm like, hey, thanks, bud. I have 485 miles an hour plus however fast that wind is pushing me. So those are our two rates. And I'm like, talking about distance, talking about time. I'm like, oh, I have a formula. My formula is distance is equal to rate times time. I want to input it into this formula here. So I'm like, let's solve for t, divide each side by r. So time is equal to distance over rate. And I'm like, oh, I know the distance. It is the same for both. So let's go ahead and put that in. So 395 over my rate for the way there is that 485 plus x. And then I'm adding it to 3950 because it's the same distance. Over on the way back, I'm like, hey, thanks, wind. You're making me go way slower. And it's equal to the total time of 16.5. So there is your equation. And after that, all we're going to do is solve this equation. So I'm going to let's go over here. Give me a second while I write it down. 485 plus x. So my first step is I'm going to want to find my least common denominator. 485 plus x times 485 minus x is going to be my least common denominator because I do not have any of the same factors in either of the denominators, although they look pretty similar. So from that, I'm going to multiply this left side. It is missing the 485 minus x, so I'm going to multiply that by 485 minus x. This right side here, I'm going to multiply by 485 plus x. And let's go ahead and bring this down. So here I have 3950 times 485 minus x, and then plus another 3950 times 485 plus x, all over my least common denominator of 485 plus x times 485 minus x. And y'all, we like to leave this in factored form whenever we are doing rational equations. Okay, I'm going to go ahead and cross multiply at this point. Really, 16.5 is over 1. On the left side, I'm going to go ahead and distribute what I can. So I'm going to distribute this guy here and this guy here. So that's 3950 times 485. And then I'm also going to distribute this. So I want you guys to see what's happening because I'm going to save room. When I multiply 395 times a negative x, and over here I multiply 3 390. Let's pretend I said 3950. 3950 times a positive x. Those two things are going to cancel because I have a positive and a negative, so I'm just not going to write it. And then the next one I have is plus that 3950 times 485, and then that is still equal to 16.5 times, and then I'm going to go ahead and we'll FOIL in the next step. 485 plus x times 485 minus x. Okay, so now I have a linear equation here, so that makes it a little bit easier. Let me move myself out of the way. So on the left side, I'm like, oh, I have two of the same thing. So I'm just going to say that's 2 times 3950 times 485. Did you have to do that? No, you could multiply each one and add them together. You're going to get the same answer. On the right side, I still have this 16.5. I'm going to go ahead and FOIL. So I have times 485 times 485 is 485 squared. Again, with the whole plus or minus, when I multiply 485 times a negative x and times a positive x, they're going to cancel, so I'm not even going to write it. And then negative x times negative x gives me a negative x squared. Oh, just turned into a quadratic. Fabulous. Okay, so now I'm going to go ahead and clean up that left side. Let me put that in my calculator. 2 times 3950 times 485. I'm going to get, let me move this over here. I'm going to get 3,831,500 is equal to, on the right side, I have, that's going to give me a huge number. So I'm just going to leave this as 16.5 times 485 squared, and then minus 16.5 times x squared. Okay, at this point, I'm going to go ahead and add the 16.5. I know I'm running out of room here, so I'm going to add, let's do it in a different color. Add 16.5 times 485 squared to both sides. 485 squared. They're going to cancel on the right side. I'm going to go get my graphing calculator real quick so I don't use my phone, and I'll be right back. Okay, graphing calculator to the rescue. So when I put both of these in my calculator, I got a negative 49, and this should actually be a subtraction here. Subtraction. Got negative 49,712.5. I'm going to divide each side by negative 16.5. So I'm going to get x squared is equal to 31.2878, blah, 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 blah. I'm going to take the square root of each side, and then I'm going to get that x is equal to about 54, what did it say? Round to 3 decimal spots, so 889. Oh my goodness. Okay, we are almost there, y'all. So once I have that x value, I need to go back to my original question and say, hey, what did they really ask for? If I found x, what is x? We labeled x as the wind speed. And so now I'm like, well, what did they ask me? They asked me to find out how much faster is the plane going on the trip there compared to the way back. So I'm like, oh, I have to go back here. And on the way there, it was 400, so there, is equal to 485 plus the wind speed, which I found was about 54.889. On the way back, it was smaller, so it was 485 minus that 54.889. Adding those together, 485 plus 54.889, that gives me 539.89. And then I'm going to subtract that from whatever I get on the way back. So 485 minus 54.889, I get 430.111. And then when I subtract those, I get, give me a second, I get about 109.779. Oh my goodness, guys. Okay. And before I box that, I probably should have put miles per hour because we are talking about a word problem. Okay, so wow, that is a big mess, but that is how you solve this problem. So again, the hardest part is just setting up this equation here. Make sure you know your distance is equal to rate times time formula, and then it's just a matter of multiplying everything. Make sure you put everything in your calculator correctly and doing all of your algebra correctly. And then at the very end, make sure you answer their question. Because if you gave me 54.899, that's cool, but that's not what the question really asks. So just be careful when you're reading the question to answer the question as well. All right, if y'all need help, come find me. If not, I'll see y'all in the next one.